Today I wanted to show you how to draw an orbital diagram using a periodic table. With your periodic table, so far I have it colored already with the different blocks. The different blocks on the periodic table are S, P, D, and F. Your S block I have colored in orange. So with your S block, we also have helium down here. Helium can kind of fit in right here for your S block. So whenever we're counting that one, we need to make sure that we remember that helium is part of the S block. Now the next one is your P block that I have colored over here in red. The reason why I go S, P, and then we're going to go D in just a second, if we can remember that order, it helps us to remember the energy levels that we're going to number. After your D block, we're going to use our F block. Now the numbering of your energy levels go down the side of each of the different blocks. Your S block is going to come first, and these actually follow the period numbers. So we have 1, 2, 3, 4, 5, 6, and 7 for your energy levels. Now your P block is next, and these follow the period numbers as well, but it starts with the number 2 right there. Then we have 3, 4, 5, and 6. So those numbers are all in line with one another so far. But these D block electrons, they actually hide further inside of your atom in another energy level. So we actually start with the number 3 with your D block. So if you notice, it starts with 1, 2, 3. We just number all the way down. Then after your D block, we have your F block down here. They start with 4. So if you can remember S, P, D, F, they start with 1, 2, 3, 4. Now once you know your energy levels, you need to know a few different things about your orbital diagrams. If you have an S block, in S block orbital, you'll always draw one of them because you always just find one single S block. Now that one S block orbital holds 2 electrons total, and how we show an electron is with an arrow. Now your arrow can either spin up or down, either way, because they spin in opposite directions. So each one of these arrows is 1 electron. If we have a P-shaped orbital, there's actually 3 of them there total. So each line is 1 orbital. And we would put 2 electrons on each of those different orbitals if it completely fills. D comes in 5s. And F, there's 7. Now each of those orbitals hold 2 electrons, and with those 2 electrons, again, we're showing them with arrows spinning up and spinning down. They both have negative charges, so they're just trying to repel away from one another. So with your orbital diagrams, what we're going to use is your periodic table that we have colored and numbered. And we have, for our first example, fluorine. Now fluorine is right here, number 9 on your periodic table, so it has 9 protons. And right now it has 9 electrons because it's electrically neutral. So with your 9 electrons, we need to place them in their different orbitals in the correct places. So what we're going to do is we always start at the top of your periodic table, and anytime you see an energy level, you're going to write down that number and then tell what block it lives in. We read from left to right, top to bottom, so you're going to read the periodic table the same way. So the first number that I see is the number 1 for my energy level, and that's in the S block. Anytime you have an S, there's only 1 orbital there. And that 1 orbital holds 1, 2 electrons. So 1 spins up and 1 spins down. After 1s, we cruise across and we're at the end of the 1s. So we go to the next line and I see the number 2, and I'm still in the S block. So I draw 1 line for my 1 orbital, and there's 2 electrons in that orbital, 1, 2. Then I cruise across here, and the next number that I see is 2, but now I'm in the P block. For my P orbitals, there's always 3 of them there. 1, 2, 3. For my 3 orbitals, each one holds 2 electrons. And I'm going to go to fluorine over here. So to figure out how many electrons I need, I actually start at boron here, and I count over until I get to fluorine. 1, 2, 3, 4, 5. Now with my 5 electrons, I have to spread them out first because they each want their own orbital. So there's 3 electrons, but I had 5 total. So I'm going to double this guy up, and I'm going to double that one up. This one gets its very own orbital because he doesn't have a partner yet. So here are my 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons with their orbital diagram, showing the energy level and the shape of orbital that they're in. Now if we do a little bit longer one, I have titanium here. For titanium, we're at number 22 on the periodic table. Again, I start at my top of my periodic table with my 1s orbital. There's one of them, and I have 2 electrons. Now after 1s, then I'm here and I'm at 2s. So I write down 2s. Again, one line for my 1 orbital, 2 electrons. Now with those 2 electrons, I cruise across here, and again I'm at 2, and this is the p block, so I write down 2p. P's come in threes, so 1, 2, 3. I'm going all the way across all of these, so there's 1, 2, 3, 4, 5, 6 electrons. 1, 2, 3, 4, 5, 6 electrons in 2p. After 2p, I pick back up here, and I'm at 3. I'm in the s block, 1 orbital, 2 electrons, 1, 2. Now after 3s, I have a new energy level. I'm at 3, but this is the p block. So with my 3p, again, I draw 3 lines. There's 6 electrons. 1, 2, 3, 4, 5, 6. After 3p, I pick back up here, and now I'm in the 4th energy level with 4s. S's get 1 line, 2 electrons, 1, 2. Now I see a new number here. This is 3. I'm in the D block. D's come in 5s. So I draw 5 lines for my 5 orbitals. Now with this 5 orbitals, I'm going to draw them first, but I need to figure out how many electrons go in that orbitals, or in those orbitals. So I start here at the beginning of the period with scandium. Now I'm just doing titanium, so I'm just going to count over 1, 2 elements, which means that there's 2 electrons in my 3D. So I just draw 1, 2 electrons in that 3D. Now if you go back and add up all of the arrows, it should equal 22.